We're going to finish the notes from page 11. We started this on Friday. We are multiplying polynomials. And to multiply polynomials, it's like me distributing paper to the class. I would hand every single person a piece of paper. When you're multiplying polynomials, you use the distributive property where you take the number, term, whatever, and you multiply it to every single thing in the parentheses. On Friday, we did example 1, x. Example 1, where you have a monomial times a binomial. We had 5x squared minus 15x. Today, we are looking at example 2. Example 2 is a binomial times a binomial. It is slightly different in the very first line, with the way you set it up, and then from there on out, everything's the same, okay? I'm going to show you 2 techniques. You decide which technique you like, and then you do that one. Go with me? Yes? So you have a choice. I'm going to show you 2 ways. Method 1 is the most intuitive way, which means if you plan to go to college, you need to learn method 1. And you can eventually get to method 1 by means of method 2. I'm going to show it to you. You have x minus 1 times x plus 4, right? We need everything in this first set of parentheses to multiply by everything in the second set of parentheses. The easiest way to do that is, I call it the split repeat, meaning split the first set up by terms. You got x, beep, minus 1, beep. And I do the beep there because I leave it blank. And then the repeat part is the second set of parentheses goes in here, repeated twice, because there's 2 terms. Now, look what I just did. I just took a binomial times a binomial, right? And I just restructured it to now I have a monomial times a binomial and then a monomial times a binomial, which means what you already know how to do. Do you see that? So I took what was a more challenging question, I restructured it back down to what we already know how to do, and now you finish it just like we did on Friday. So x times x plus 4 would be what? X squared plus 4x. Negative 1 times x plus 4 would be negative x minus, multiply, 4, right? And then now you combine any terms that might match. Remember, for them to match, they have to have the same letter, same exponent. So the only ones that actually match would be, in this case, the positive 4x and the minus x. What does that become? 4 minus 1 is 3. So I'm going to bring this other stuff down. Oh my. We got x squared plus 3x minus 4. That is the most intuitive way to do it. It's called the distributive property. It will carry over through all future math classes. Now you might be wondering, what is the other way to do this? Okay, it's called the box method. I'm going to arrow to some blank space. We had x minus 1 times x plus 4, right? Isn't that what we had? Yes. If you like this method, maybe watch it first. And if you like it, then flip to the back of your paper and put it there. Or put it somewhere where you have room. See if you like this method. It's called the box method because we are going to draw a box. You're going to draw the box in a manner that is set by how many terms are in the parentheses. So this is a binomial. This is a binomial, which tells me that I'm drawing a 2 by 2. Because I have 2 terms, 2 terms. You with me? All right. One set of parentheses goes down the side. Draw broken up by terms. So I have x minus 1. The other set of parentheses goes across the top, broken up by terms. So I have x positive 4. Notice I spaced them out a little bit, and then you draw your boxes. It's a 2 by 2. Now you might be wondering, where in the world is this going? Now you're going to multiply the terms and then write in the box where the cross section is for what you get. So for instance, x times x will go there. Oops. X times 4 will go there. Negative 1 times x will go there. Negative 1 times 4 will go there. So you have x squared, 4x, positive 4x, right? Negative x, negative 4. Then what you have to do is you have to recognize if there's any terms that are alike, and as you write your answer, you would pull that this is x squared. What does this become? Positive 4x minus x becomes positive 3x, and then minus 4, and that's the answer. Now let me explain why the box method, when it's necessary. If you struggle with showing your work, use the box method, because if the box is empty, it means your work is missing there, and it would force you to fill it in, right? If you struggle with organizing your work, use the box method until you get good at this, okay? If you just like the box method, then use it by all means. It works every time. I personally don't use the box method just because I never learned the box method in high school. My teacher made us go this way, and then I learned the box method as a teacher, and it does help some people organize it. Would you like to see this way one more time so that you understand how to set it up? Well, let's do the example. Number 2. Go to number 2. It's a binomial times binomial. So the idea is we want it to be a monomial times a binomial. So the way you do this is, I call it split, repeat. You could also call it beep repeat, because I did beep. But anyways, split, meaning take the first set of parentheses and split it up into terms. And after each of them, you're going to put a set of blank parentheses. So I've got 2x, beep. Beep really helps. Plus 3, beep. See that? And now in the parentheses, I'm going to write what? I'm going to write, if it helps if you label it too, split, repeat. I'm going to repeat 2x minus 3 in here. And then now I've set it up exactly how we did Friday's lesson. A monomial times a binomial. Now, if you do the box method, your box will be a 2 by 2. The first set of parentheses goes down the side or the top, doesn't matter. 2x plus 3. The other set goes down the side or across the top, depending on which one you've already filled in. And then now you would multiply. Notice, as I multiply 2x times 2x and get 4x squared, that's also what I get right here. See, that's why this works. Then I multiply 2x times negative 3, and here 2x times negative 3, I still get the same thing. The box method is just a way to organize your work if you're not good at showing your work already, or if you lose your train of thought along the way. Here we would have 6, wrong color. Here we would have 6x minus 9. Here we would have 6x minus 9. What happens right here? These cancel. And you're left with 4x squared minus 9. Right? There's a vocab phrase I want you to write down wherever you can find room. And I want you to draw an arrow to this example. This is called a difference of squares. Draw an arrow to this example right here when you write that vocab word down. A difference of squares comes up in all future math classes, especially Algebra 2, which you have to take next year. What's a perfect square? Throw one out. 4 is perfect because it comes from 2 times 2, right? Yes? 9 is a perfect square because it comes from 3 times 3. Okay. X minus 2. What was it? 2x minus 3 and 2x plus 3?
2x plus 3.
Okay.
And 2x minus 3.
All right. You don't have to write this. Y'all just look. Stay with me. Look at this one right here. Do you notice how the parentheses match? They're the same thing, right? That's called a perfect square. Another way to write that is 2x plus 3 squared. Does that make sense? Okay, look right here. Do they match? No. But there's only one difference, and it's the sign. Right? Hence the name, difference of squares. Meaning it's not a perfect square. It's so close to being a perfect square, but there's one difference, so it's called a difference of squares. And here's why it's important. Every time you have a difference of squares multiplied together, every time, every day of the week, all day, every day, the middle term disappears every time. Okay? So that's why it happened here. Now, when we go to another example, that's a trinomial. But if we have another example and your middle term disappears, but the two that you multiplied together were not a difference of squares, then something's wrong. Because it only happens on a difference of squares, okay? All right, go to this one, number 4. What's leveled up here? Like, what's more challenging now? It's a trinomial. Either method will still work. Let me show you both methods. So this is saying find the product. That means multiply, right? Find the product means multiply. X squared plus 4x times x cubed plus 3x squared minus 1. Okay, so that's my first set of parentheses. I'm going to split it up. I've got x squared, beep. I need to do a really long beat, right? Plus 4x, beep. What goes in the beat?
Hey, we want to do x cubed instead of x squared, please.
You can, but why would you want to? Watch what's going to happen. But you actually can. Yeah, it doesn't matter. I personally like to put the longer one as the repeated one because then I only have 2 sets of parentheses instead of 3 sets of parentheses. But it does not matter. You'll still get the same answer. So now you just have a monomial multiplying into a trinomial. Monomial into a trinomial. Now, if you're doing the box method, you might be thinking, well, how do you do that with the box method? Well, instead of a 2 by 2, you would have either, you could do a 3 by 2, but I wouldn't do that. I would go, where'd it go? I would just extend this out with another, and I'd put the trinomial across the top. Does that make sense? because then you still multiply. So let me show it to you. What was it, by the way?
X squared plus 4x. And x cubed plus 3x squared minus 1.
X cubed
Plus 3x squared minus 1.
Alright, so that's what it would look like. And then you would multiply. Now, when you got done, you would have more terms that match, and you'd have to combine them. So let's do it. We'll do both. Come right here. Multiply that out. Let's see if we get the same answer. Are you done multiplying it out? Did you try? You should be trying that one right now. Remember to multiply the polynomials. You're going to add the exponents, which I think brings us to right here. We said add the exponents. Then you combine like terms and write in standard form. So did you get x to the fifth plus 3x to the fourth minus x squared plus 4x to the fourth plus 12x cubed minus 4x? And then combining like terms. That? Yeah. If you did the box method, you'd still get the same thing. You would have to recognize where there are some terms that can combine, and you would combine them as you go to write your answer. You also would write it in standard form. There is something that I'm strategically not saying to you, but you may hear in future math classes. FOIL, have you heard that?
Nope.
Good. FOIL is an acronym where they're letting you know what order to multiply. It's to help people multiplying polynomials. Here's the problem. Here's what it stands for. Multiply the first terms, the outer terms. This would be the first in the front of the parentheses. The outside terms, the outer edges, the inside terms, and then the last terms in the parentheses. Here's the problem with FOIL. If you have a binomial times a trinomial, FOIL does not work. It leaves out the middle term because of the fact that it's now a trinomial. So I don't teach FOIL because people tend to try to use it every time, and it does not work with a trinomial. What does work every time is the box method or the distributive method. Works every time. Doesn't matter what you have in front of you. Okay? Look at number 5. A rectangle has a length of 6x minus 2 and a width of negative 2x plus 3. Let's take some notes over here. We have a length of 6x minus 2. We have a width of negative 2x plus 3. It says find the perimeter and the area. What does perimeter mean? What? It's adding up all of the outer edges, right? What's the shape here? Y'all stay with me.
A rectangle.
It's a rectangle. If you need to draw a picture, you can. So what's the length? What's the width? What's this? What's this? So if I'm trying to find the perimeter, I would simply do what? I would add all of them up. There's a shortcut to it. The shortcut is to recognize, well, how many lengths are there in a rectangle? How many lengths in a rectangle? There's 2 lengths. And there's how many widths?
2.
2 widths. So that's a shortcut approach. If you understand, oh, well, the lengths, there's 2 of them. The widths, there's 2 of them. So you could just double the length, double the width, and then add it, instead of sitting here and adding up all 4 sides. So there's 2 ways to approach that. So that would be 12x minus 4 plus 6, or negative 4x, sorry. Did you get that when you doubled them?
No.
No?
I just did number 5 like I did number 2. You know what I'm saying?
Well, that's area.
That's what it is, huh?
You just did half the problem. Don't erase it. You did half of it. It says find the perimeter and the area. Now you have to find the perimeter, which is the easier one, because you're just adding. Right? So we've got 8x plus 2 is the perimeter. Did you get that? I doubled them. I doubled the length and I doubled the width. I have no room, so it was. So if you're wondering where the 12x minus 4 came from, that was me doubling the length. And if you're wondering where negative 4x plus 6 came from, that was me doubling the width, because there's 2 of them, right? What does area mean? What's the formula for the area of a rectangle? Length times width. Length times width would put us at a binomial times a binomial, right? Which is exactly what we just learned. You multiply that out and then look up here and see if you get the right answer. I'm going to write the correct answer in just a second. It's like, wait a minute. Did you get negative 12x squared plus 22x minus 6?
Yeah. Yes.
circle this to the right. No. I have to answer that question without problem. This is your practice assignment. Page 12.